We're going to do the ratio test today, which is going to look really similar to the root test. So the only difference here is the limit that we're computing. So remember with the root test, we computed the limit as n approaches infinity of the nth root of the absolute value of a sub n. Here we're computing just a different thing. We're computing a ratio. So we're looking at the n plus 1 term over the nth term. Once again, we have absolute values there. And our conclusions that we make, depending on whether L is less than 1, bigger than 1, or equal to 1, are the exact same. So these are the same as the root test, just a different limit that we're computing. So don't memorize 2 different sets of things, or don't memorize this twice. It's all the same. So let's see how the ratio test works. The ratio test will work in some cases where the root test would have also worked. It just really depends on what you prefer. So let's look at the limit as n approaches infinity. We need the n plus 1 term, which means I need to replace all the n's with n plus 1. So our n plus 1 term here is going to be negative 10 to the n plus 1 over 4 to the 2 times n plus 1 times n plus 1 plus 1. So that extra plus 1 is coming from there. Okay, let me simplify that before I plug it in. So this is going to be negative 10 to the n times negative 10 to the first over, so this looks like this is 4 to the 2n plus 2 plus 1. So that looks like it's 4 to the 2n times 4 cubed, plus 2 plus 1 is 3. And then I would have an n plus 2. Okay, so that's our n plus 1 term. So I have negative 10 to the n, negative 10 to the first over 4 to the 2n times 4 cubed times n plus 2. I have to divide that all by the nth term, which is just that original thing. I don't have to do any extra work there. So I have negative 10 to the n over 4 to the 2n plus 1 times n plus 1. I better not forget my absolute values. And this is super messy. Let's flip that bottom fraction. So we get a limit as n approaches infinity, negative 10 to the n times negative 10 to the first over 4 to the 2n times 4 cubed times n plus 2. I'm going to flip this guy. And you can always start out by writing this as a multiplication where you flip the a sub n term. That's fine if you jump straight to that. So let's see, the negative 10 to the n will belong in the denominator. We'll have the 4 to the 2n plus 1 times n plus 1. Okay, and now let's hope things cancel out, because otherwise we'll be in deep trouble. The negative 10 to the n's will cancel out. We're going to be left with that negative 10 to the first. This is 4 to the 2n times 4 to the first. So the 4 to the 2n's are going to cancel out. The 4 to the first will cancel out, and this will leave us with a 4 squared. So we are left with negative 10 to the first times n plus 1 over 4 squared is 16 times n plus 2. So now notice that we have a polynomial over a polynomial. We're just going to take the highest power. So that's the n. The n's being multiplied by a negative 10, and this n's being multiplied by a 16. So if we simplify that, we just get negative 10 over 16, but the absolute values make it positive. So we get 10 over 16, which is less than 1. So this series is absolutely convergent. Whew. Okay. That one was messy. Some of these, that one was kind of a messy one to start with, probably. Some of these won't be quite so messy. Let's try this other one here. So let's see, our a sub n plus 1 term is going to be 9 to the n plus 1 over negative 2 to the n plus 1 plus 1. So I'm going to get n plus 2 and n plus 1. So this, I was getting n plus 1 plus 1. That's how I got to the n plus 2. Okay, so that's our a sub n term. So we're going to look at a limit as n approaches infinity. We're going to have 9 to the n plus 1 over negative 2 to the n plus 2 times n plus 1. I'm going to divide that all by my original expression, which is the same thing as multiplying by the reciprocal. So let's save ourselves some writing and multiply by the reciprocal of this guy. Okay, and let's ask ourselves, what are we left with? So the 9 to the n will cancel out and leave us with the 9 to the first over here. The negative 2 to the n plus 1 will cancel out and leave us with a negative 2 to the first here. So we're going to get a limit as n approaches infinity, 9 times n over -2 times n plus 1. We keep the highest power from the numerator and from the denominator. And so we get a limit, well, when that simplifies, we're just going to be left with 9/2. When we take the absolute value, that's bigger than 1. And getting things bigger than 1 tells us that our series is divergent by the ratio test. And I am not going to do that last example. I think we've done enough examples for this video.